If you want a successful career as a certified secure software lifecycle professional, or if you're not looking to get certified, just be a really successful professional, then you'll want to be clear on the goals of your application security efforts. Securing applications is an important part of the process, but application security alone is not the ultimate goal. What you're really trying to protect is the data that's processed, stored, and transmitted by those apps. One of the most common models for securing data is the CIA triad, named after the three components within that model: confidentiality, integrity, and availability. Let's start by taking a closer look at confidentiality. If you poke around online, you'll find a lot of wordy definitions for the term confidentiality. I like to keep things simple. And really, at its simplest, confidentiality is all about keeping secrets secret. There are people who are allowed to access certain data elements and other people who are not. Take credit card data, for example. You're allowed to see your full 16-digit card number, as well as the 4-digit code on the back you use when purchasing items online. If someone else had access to your credit card data, that person could buy things for themselves and then stick you with the bill. Keeping those secrets secret within the apps you're protecting is key in protecting the people who are using your applications. But this data does not just live in one place. It's scattered all about, and it's your job to track it down. The expectations of confidentiality extends to three types of data based on where the data is at any given time. Data in use is actively being accessed by users, data they are currently having open in their app. Data at rest is not currently being accessed, usually in either structured data stores like databases or unstructured data stores like file servers. Data in motion is traveling between 2 points across some type of network, either wired, wireless, or mobile. One of the most common methods for ensuring the confidentiality of the data you're protecting is the encryption of that data. When encrypting data on a file system, you may choose to encrypt the entire disk. Alternatively, you can choose to encrypt that data on a file-by-file basis, or you could even encrypt sensitive data elements within each file. Within a structured data store, you have similar options. You could choose to encrypt the entire database, or you could restrict your encryption to either a specific column or field within that database. When encrypting data in motion, SSL and TLS, which is its successor, their certificates are far and away the most common method for achieving this goal. You might hear both terms used interchangeably. Just keep in mind, as I said, that SSL is being replaced by TLS. Virtual private networks, or VPNs, offer another layer of network encryption. It creates a tunnel between two endpoints and encrypts everything that travels through that tunnel. These methods of protecting data are sometimes referred to as overt encryption channels. By overt, I mean that no one's trying to hide the fact that they're encrypting that data. An attacker would be able to see that that data is encrypted. If you want your users to know that their passwords are protected when they log into your web app, then you want to make it crystal clear that your TLS certificate is in place. There are other trickier methods of protecting data, though, methods we refer to as covert encrypting channels. Take steganography, for example. Did you know that you can hide sensitive data in the ones and zeros that make up image files? The same holds true for video and audio files. It still takes special knowledge and tools to find and extract this data, but this type of encryption isn't nearly as obvious as the HTTPS in the URL field. To an end user, an application might appear to be just a single web page, but you and I know better. The web page is only the entry point into a much more complex architecture that consists of network devices, web servers, application servers, database servers, and even security appliances. In order to understand where you need to implement your application's confidentiality controls, it really helps if you have a data flow diagram. What is a data flow diagram? A data flow diagram is different from a detailed network diagram, and intentionally so. The purpose of a data flow diagram is to provide a conceptual image of how the application works, focusing on sensitive data that enters the app, where it goes once it's inside, and where that data ultimately ends up, often in a backup system of some sort, of course. By tracking the data flow through your application and putting in encryption controls in place where they're going to be most effective, you'll be well on your way to protecting the confidentiality of the data within that application. At its core, security is ultimately about trust. How do you know that you can trust the people who have access to your data? Are they going to use that access appropriately? Will they be able to bypass your controls and alter that data? This need for trust is one of the reasons that integrity controls are so important. Integrity is as essential to security as confidentiality or availability. While the priority of each type of control will vary based on an organization's overall risk appetite, the need for integrity controls will remain constant. So what? What exactly does integrity mean? You rely on integrity controls to ensure that data is protected from unauthorized changes. This holds true for data at rest and data in motion, and it's often accomplished by comparing a given value to a value that the app already knows to be true. Take e-commerce apps, for example. An e-commerce application will provide a user the opportunity to purchase something at a known price. Even before users apply gift cards and discount codes, the app already knows how much a specific item costs. Without proper integrity controls in place, an attacker might be able to trick the application into accepting a price of the attacker's choosing. For instance, if the price is $100, the attacker could try to modify it to be $1. So, how would that impact your sales if an attacker could trick your e commerce application into changing the price? Well, that's pretty obvious, right? So, the number of sales would almost definitely go up, the profit from those sales would plummet, and one of the most popular integrity controls is hashing. Hashing is technically a cryptographic function, and it's not quite the same as encrypting and decrypting a file. When you run a file through a hashing function, that function spits out a string of letters and numbers that represent the original file. If anyone downstream runs the same hashing function against the file, then they better get the exact same string of letters and numbers. If they don't, then there's a really good chance that someone has tampered with that file. Digital signatures are a type of hashing function. They're specifically used by the sender of a message or the creator of a document. Before the message or file goes anywhere, the creator uses a private key to generate that signature. Anyone with a public key can check the digital signature and verify that the person who sent the message or created the file is really who they say they are. This concept of signing messages and files applies to executables as well. We refer to that process as code signing. Code signing serves two purposes. One, it verifies that the person who wrote the code really is who they say they are. And two, it verifies that the code has not been altered by someone else. Code signatures are incredibly useful when trying to identify malicious software that's pretending to be something else entirely. Without integrity controls, knowing whether or not we can trust the applications that we use on a daily basis would be pretty challenging. We need integrity controls to help us guarantee both the authenticity and the reliability of those applications. By validating an application's authenticity, we can rest assured that the application does not contain malicious code put there by someone other than the developer. This attack technique is pretty common in the mobile application space. Integrity controls also help us ensure that the application is doing what the developer designed it to do and claims to do. Once an app has gone through rigorous QA testing, the developer has a higher level of assurance that the published app will perform as expected in real-world scenarios. One authorized change to that app, even a quick fix from a well-meaning developer, could negate a significant portion of those QA tests and result in an unstable application. Think of your mobile application permissions and how those can get really out of whack. When you incorporate integrity controls into your application, you increase both the trustworthiness and the stability of that app. While these may be controls that your users take for granted, they are essential in protecting the application data from potential compromise. With so many news stories about data breaches, you might think that those breaches could have been prevented with stronger confidentiality and integrity controls. And of course, you'd be right, but you'd be overlooking the third control in the CIA triad: availability. Yes, it's important to keep the secret secret. And yes, it's important to make sure you can trust the application is securely handling and protecting your data. But you also need to ensure that the application is available when your customers want to access it. A disruption in any of those areas would have a negative impact on your company and your users. Availability controls are designed to make sure your app is there when your users expect it to be there. Imagine trying to log on to Amazon and buy something and the website doesn't load. If you've ever worked in retail, of course, you know that your e commerce apps had better have a high availability during the holiday shopping season. Every minute those apps are offline can mean thousands of dollars in lost revenue. When it comes to ensuring that your application meets its availability requirements, you have multiple options. Three of the most effective options are redundancy, replication, and clustering. At some point, your application is going to break, and while the admins will be rightfully concerned about why it broke, your users are not going to care. They just want it to work. When you implement redundancy controls, you'll have a standby version of the app ready and waiting for when that time comes. Regardless of which component in the app fails, database, server, whatever, you'll be able to redirect the users to a functional version of the app while you troubleshoot the issue. Replication is similar to failover, although it takes a slightly different approach. When users enter data into your application, you can replicate that data to one or more instances of the application or nodes. If the data in one of those nodes ever becomes corrupt, the app can check the other nodes and find the clean version of that data and use that version instead. Since all this happens behind the scenes, it's unlikely the users will even notice the failure. Clustering takes the concepts of failover and replication to a whole new level. When you cluster your systems, you'll tie them all together so that they distribute the workload among themselves while acting like one single unit. In a cluster, one component is responsible for determining where to send each piece of work for processing. That component can monitor which systems are up and down, as well as which ones are busier and running slower than usual. When this happens, it can send that workload to a more responsive part of the cluster, providing the end user with the best possible experience. When you've properly implemented availability controls for your application, you increase both the scalability and resiliency of that application. This means that your app will be able to keep pace with a higher workload as the business grows, enabling the business to be more successful. Security teams tend to focus on confidentiality controls to counter potential data breaches, as well as integrity controls to help meet compliance requirements. As someone who's been around the industry for quite a while, I'm here to tell you that availability is just as important. Stay tuned for the next video. And if you're enjoying the series, please like and subscribe.